What is the subset? So, if A and B are two sets such that each element of the set A is an element of the set B also, then A is said to be a subset of B. I repeat again, there are two sets A and B. If the each element of the set A is an the element of the set B also, then the set A is said to be the subset of B. As for example, suppose a capital A is a 2, 3, 4 and B is a 1, 2, 3, 4, 5, 6. So clearly we seen that 2, 3, 4 all the element is inside in the set B. Therefore, A is a subset of B and it can be written as a subset of B. So again 2, 3, 4 is all element of the set A is also an element of the set B. Therefore, A is a subset of B. And we write A subset of B. Now some important point about the subset. The first point is every empty set is a subset of every set. Every empty set is a subset of every set. So we consider the any set A is a 1, या A is a 1, 2, या A is a 1, 2, 3. We consider any set A is a student of the class, या student of the city. Okay, but phi is always the subset of A, and we denoted phi is always the subset of A. The next important the concept, each set is a subset of itself. So each set is always the subset of itself. So we denote a subset of A. Now next, if A subset of B, B subset of A, then A is equal to B. As for example, suppose we consider A is equal to 1, 2, 3. And B is also 1, 2, 3. Same. So in this case, we write A, all element of A is inside in B. So we write A subset of B. B also, all element of B is also inside in A. So we write B subset of A. And when A subset of B, B subset of A, then A equal to B. Next, suppose A subset of B, but A not equal to B. Therefore, suppose here we add one element, 1, 2, 3 and 4. So A subset of B, but A not equal to B, then A is a proper subset of B. Then A is a proper subset of B. And B is a superset of A. And it is denoted by A subset of B, not equal to, only the A subset of B. And A subset of B, that means we can say A is a proper subset of B. The next concept, we know that n is a natural number. N is only the set which is whose element is a 1, 2, 3 up to and so on. Then we consider Z is an integer set whose element is a negative, 0 and positive. So obviously N is a subset of Z, but not only subset, proper subset, because both are different. Q is a rational number, so bigger than Z, and R is the real number. So this is the biggest set. So we write N subset of Z, Z subset of Q, Q subset of R. Now, how to find the number of subset of the set? How to find the number of the subset of the set? So we discuss some example. Suppose we consider the set A is 1. Then the subset of A, the possible subset of A is phi and itself. So the number of subset of the set A is 2. Total is 2. Suppose we write 2 raised to 1 because we define the formula. So suppose A is 1, A is only the singleton set, then every singleton set, the number of possible subset is 2. And which one? So 1 is the phi, because phi is obviously the subset of every set and the set itself is a subset. So only 2 subset of the singleton set. Now we consider the another set A is equal to 1, 2. That means the number of element of the set A is a 2. So N A is equal to 2. That means what? The number of element of the set A is equal to 2. Then the subset of A, the possible subset of A, always first we write phi. Then we consider the singleton. So we consider 1 singleton, then the possible singleton again 2, and then 1 and 2, only 2 possible singleton, then we consider 2 number of 2 element of the set, so 1, 2, no another element for the number of 2 element. So this is itself, this is the phi, okay, and both are singleton. So the possible subset of the set A is 4, and we write 2 square. So if the number of element is the 2, then the possible subset of the set A is a 2 raised to 2. Now we consider the another example. Suppose A is equal to 1, 2, 3. That means the number of element is 3. And number of element is 3. Using this formula, we define, so obviously 2 raised to 1, 1 element, 2 raised to 2, 2 element. So 2 raised to 3 is a 3. That means the number of element is 3. So the possible subset is a 2 raised to 3 is 8. But which one? So the subset of A, first phi, then singleton. So possible singleton 1, 2 and 3. Then number of 2 element is 1, 2, then 1, 3 and 2, 3. So possible 1, 2, 1, 3 and 2, 3. And then for 3, so 1, 2, 3. So the number of subset of A is total 8, and we write 2 raised to 3. So if number of element is 1, so we write 2 raised to 1. Number of element is 2, so we write 2 raised to 2. Number of element is 3, so we write 2 raised to 3. So in general, if a set A with the number of element is P, then the number of subset of A is a 2 raised to P. And the number of proper subset of A is a 2 raised to P minus 1. So number of element is a p, then the number of subset is a 2 raised to p. Suppose we consider some example. A set A is number of the element of the set A is 100. So the possible subset, the number of subset is a 2 raised to 100. Okay. Now the next is the power set. So how to define the power set? So this is very simple. Suppose we consider a set P is equal to x comma y. Now what is the possible subset of P is equal to x comma y? So phi, x, y and x comma y itself. So all element, all subset of the set P, that means phi, x, y and xy. So we consider this is the another set whose element are the subset of this set P, and we denote Q. Okay. So if we consider these subset as the element of the new set Q, so therefore Q is equal to, we write phi, x, y and xy, and therefore the Q is said to be a power set of P. So Q is a set whose element is a subset of the set P. Okay, and then this set, new generated set, is said to be a power set of P. The power set of A is denoted by P of A. Symbolically, we write the P of A is nothing but the power set of A, and it's the set of all subset of the given set. Now, universal set. This one is the universal set. So, universal set, how to consider? So first we can take the concept and we consider this three set. P is equal to x. X is the student of your class. Y is the male students of your class. And Z is the female student of your class. So P total student, Q male student and R female student. So clearly Q and R both a subset of P. So P can be considered as the universal set for this particular example. Okay, so this one as for example, this one is your class, and in your class the number of all student. Now this is the number of male student. This one is a number of female student. So both are subset of P. So therefore P is a universal set of this particular example. Universal set is generated by U. So obviously the U is the symbol of the universal set, and in particular problem a U is said to be a universal set if all the set in that problem are subset of U. So in a different situation, the universal set is a different. Okay. So now this one is the universal set. So universal set and universal set is generated by capital U, and in a particular problem a set U is said to be a universal set if all the sets in that problem are subset of U. So now thank you. We stop here lecture number 3, and in the next lecture we discuss a different concept about the set operations. Thank you.